I'm by name Sanusi Samuel Indero. I'll be taking you physics, and our topic remain dynamics, Newton laws of motion. I believe by now you've already downloaded the slide which explain the theoretical aspects of this lesson. And the only thing we are going to be doing today is to be solving the examples examples in that slide. Meanwhile, we segmented these examples, the solution into two parts. That is, this is part 1, which will be taking care of question example 1.1 and example 1.2, while the other part will be solving the remaining examples 1.3 through 1.5. Now without wasting much of our time, we can start solving. Example 1.1, a ball of mass 0.5 kilogram moving at a velocity 20 meters per second is suddenly hit by a force of 5 Newton for a time of 0.05 seconds. Calculate its new velocity of motion. Now let's bring out the parameters that we have. We have the mass of the body that was moving. Mass M was given to be 0.5 kilogram, and the velocity of motion, velocity V, initial velocity, we're given that initial velocity of the motion U, 20 meters per second. What else are we given? We're given the force that this body was suddenly hit by a force F of 5 Newton, so that for a time t 0.05 seconds, and this force bring this body to its final velocity, which is new velocity we have to look for. Final velocity V is unknown. Final velocity V is unknown. Now, if we recall the equation of motion, which is the law of motion, Newton's second law of motion from that slide, we say F, that is the force, net force, is equal to M into V minus U all over T. M is the mass, V is the final velocity, U is the initial velocity, and T is the time taken for this to happen. And we already have F to be 5. Let's substitute. We have F to be 5. We have M, the mass, to be 0.5. And we have the final velocity of this motion, which is unknown, minus the initial velocity of the motion, 20, all over the time taken was given to be 0.05 seconds. Now we can cross multiply. Let's cross multiply. 0.05 seconds. Let's cross multiply. You have 0.5 into V minus 20 equals V minus 20 equals 5 times 0.05. Now we divide both sides by 0.5. Let's divide both sides by 0.5. You have 0.5 into V minus 20 all over 0.5 equals to 5 times 0.05 all over 0.5. This, we cancel this. You have V minus 20 equals 5 times 0.5 will give us 0.25. And 0.05 will give us 0.25. Divide by 0.5 will give us 0.5. And if we add 20 to both sides, we have your V equals to 0.5 plus 20, which is going to give you 20.5 meters per second. And that is going to be the final velocity of this motion, the motion of the body. Now let's move to example 1.2. In example 1.2, we were given a 800 stone, 800 gram stone, is pushed along a tarmac by a horizontal force of 30 Newton. A friction force of 10 Newton opposes this motion. What is the acceleration given to the motion. That is what's the acceleration given to this body to have this motion. And if you look, we are given, that is the that is example 1.2, the solution now. We are given the mass. We are given the mass m of the body to be 800 gram or 0.8 kilogram. That is, you divide by 1000 to give you the mass in kg, that is kilogram. After which we are given again the force applied, the applied force, F applied equals 30 Newton, and the frictional force of 10 Newton, they say it opposes this motion. And we have something like this. This is F applied and this is frictional force. You can see the frictional force is opposing this motion. 10 Newton is applied, was applied, while 10 Newton opposes this motion. If you look at it, you can see that the net force on this particular body is going to be the force applied minus the frictional force. It means that your net force is equal to force applied minus frictional force. It is the net force that will give this body acceleration. The net force will give this body an acceleration, not the force applied, not the frictional force, but the net force. And that is going to be 30 minus 10, which is going to give us 20 Newton. Now, after we have this, we have to find the acceleration of this motion. That is, A is unknown. We are looking for that. We'll recall the law of motion again, the equation of motion the Newton's second law of motion. F net is equal to mass. Remember that V minus U over T. V minus U over T is same as acceleration. Let's remember that. A is equal to V minus U over T from your law of motion, from your equations of motion. The equations of motion, we have that. And therefore, we can get your A equal to F net all over mass. And what is our F net? 20 all over. What is the mass? The mass we have here is 0.8 kg. This is going to give us 200 divided by 8. And that is going to give us 25. That is 20 divided by 0.8 will give us 25 meters per second squared. And that is your acceleration. Please always remember to put the units whenever you solve questions, because without that, you are wrong. And this will be the end for today's session. Thank you for watching.